to starting your lab, I wanted to go through some guided practice with you just to make sure that you understand how to sequence your rock layers. Remember, we're going to talk about our different laws and principles. We're going to start out with some relatively easy blocks, and then we'll go into some more complicated blocks. So in our first block here, our block number 1, we're going to look at what's our oldest to what's our youngest, and then what law or principle tells us that. So I'm going to give you a minute. I'd like you to go through and put which you're using the letters. You can see the letters here in the center of your block. Go ahead and put in there what's the oldest, youngest, and then to the youngest, and what your law or principle was. So in this one, we're going to be using the law of superposition. Our law of superposition is what's going to tell us that A is our oldest, and then B, and then C, and then D. Remembering that the law of superposition tells us that the rock layers on the bottom, in an undisturbed column, that the rock layers on the bottom are the oldest, and then they get progressively younger as you go up, and the youngest one's going to be at the top. So we're going to look at this one. I'll give you a minute. All right, so in this one, once again, we're going to use our law of superposition. The law of superposition, once again, tells us the oldest rock layers are on the bottom, the youngest are on the top. While these ones have been squished over time, you can see that they, remember, original horizontality tells us they would have been laid flat. So they've been compressed, which is why you've got this anticline right here and a syncline right here. But they haven't been flipped over or anything, so we're still good. So our oldest is still going to be A. Oops. Our oldest will still be A, and then B, and then C. Our rock layer D is right here, and this is actually, D is our unconformity. That happens right here. So what happened here is after the rock layers got squished, there was some erosion that took place, and it took off the top of the rock layers, because you can see there's another layer right here, okay, that we don't have a letter for. But you can see that most of that got eroded away, and the unconformity happened. So D is not a rock layer. D is an unconformity. Remember, it's that gap in the rock layer that happened because of erosion. And then after that erosion happened, then we went back into a period of deposition. So we had erosion occurring, took away some of our rock layers, and then the sediment started to get deposited again. So we have A, B, C, D, which is our unconformity, and then E being our youngest. All right, I'm going to give you a minute for this one. Okay, so we have to remember there's our law of original horizontality would tell us that our layers have to be laid down flat, and that didn't happen. So we know that there had to have been a movement that occurred in the blocks. Our A down here is still down lowest on the bottom, and unless we have some evidence that it actually flipped all the way upside down, we're going to assume that A is our oldest. So we're using the law of superposition once again for this. So we have B, and then C, and then D, and then E, and then the block had to move. So there was a fault, and the block shifted, and that comes down here. And we know this one because of the law of original horizontality. So we've used a couple of different laws. We're going to use superposition, and we're going to use original horizontality. And then we have an unconformity here, so we know that erosion happened. And that goes back to our law of superposition, because in order for the erosion to occur, the blocks had to already have shifted. Because if it didn't shift, if it didn't move first, then the erosion wouldn't look like that. The erosion would be all in letter E, right? Or E might be gone. And then F was laid down. Was the youngest thing that happened in this block. All right, go ahead and look at this one.
Three, two, pause.
All right, on this one, we're going to look at our, once again, we're going to have our law of superposition. That tells us that C is our oldest, and then E, and then D, and then B. And I know that all of these are older than A because of the law of cross-cutting relationships. Because the law of cross-cutting relationships tells me that in order for a fault or an intrusion to go through a rock layer, the rock layers had to be there first. So A, which is our intrusion, had to happen last. These layers had to be there in order for this one to push its way through and to melt its way into B. B didn't form on top of it because A actually melted into B. Okay, it actually pushed into that rock layer, and so we know that it had to happen first. If there was a gap, if D happened and then A happened and it was just on the surface of D, then we would have erosion would have happened, and we would have lost this top layer here. But that's not what happened. A just didn't happen to, maybe B was a harder layer of rock, and so it wasn't able to melt it. It lost energy and heat, and so it didn't have enough heat to actually melt and to punch its way through B to the surface. And so it stopped there, and it became an intrusion. All right, here's the trickiest one. We're going to do the most complicated one now. So what I want you to do is, I'm going to give you, this one I'll give you like a couple minutes on it. And I want you to look at every single thing that's happening in here. Because you can see that there's a lot of lines for you to write on this one. All right, here we go. So down at the very bottom of our block is K. So K is our oldest. And once again, law of superposition, right, is the first law that we're going to use. So K happened, then J, then I, then H. So we got J, then I, then H. Now our block is shifted, right? And this goes through our block. And this right here, which is our erosion or our unconformity, eroded away the edges, right, of all of these. So we know that the block had to shift. Okay, so there was faulting that occurred and the block shifted before the erosion happened. So we've got our block shifted, and then we've got L, which is our erosion. And this one, the reason I know that is because, once again, of original horizontality. Because blocks form horizontally, right? So I know that these had to be horizontal, and then they had to move in order for this erosion to occur. So then, now we've got our next set of things that happen. So now we've got, once again, back to superposition. Now we go G, F, E, D. So G, F, E, D, because they're all laid on top of one another. Now C, up here, cuts through all of these, and it sits on top of D. It didn't melt into B or anything like that. It sits on top of it here. And it's actually its own little outcropping on here. So I know C happened next, and I know this because of cross-cutting relationships. Cross-cutting relationships tells me that in order for an intrusion or a fault to cut through a block of rock, or a rock column, that the rock column had to be there first. So all this stuff had to be there before C could cut through it. And then after that, then we have B and A. And that goes back to our law of superposition. But we also know that B and A would have formed horizontally, right? So we know that after A happened, that the block moved in. Now, we know that this whole block moved together because all the layers were lined up nice and neatly. Okay, so we know that the movement happened after A was laid down. This down here was a separate movement, and that's why we got the block shifting or moving in two different places. So what I want you to do is, when you do your lab, have this next to you. Okay, if you need to go back, if you missed some of these things in here, go back, rewind the video so you can find the things that you missed in here, and use this to help you as you're looking at these next blocks, because your lab is going to be very much like this. You're going to have to answer some questions, you're going to have to tell me about laws and principles, and you're going to have to tell me the order that things happened in the sequences. So you want to make sure that you're using this. You can also have your notes that have your relative dating, the different laws and principles on it, so that you have the text of what they say if you've forgotten. So as I'm going through and I'm saying you're using this law, and you don't remember those laws, then have your laws next to you also. The lab is a practical application of what's happened in lecture. So you want to make sure that you're using those notes to help you out.